About materials science, but we're going to be using something that stresses materials very much. Shotgun shells. Barrel wall thickness minimums according to CIP as of 2003. This included a bunch of data for calibers, and it also used these test criteria. Having the inner diameter bore for the different shotgun shells be probably out of spec, but in this case 12 gauge shotgun shell at 20.75 millimeters. Now, some of the people in other countries swap the comma and the period around, and that's just wrong. Just saying. So anyway, here we go. The material types that were tested had these characteristics. These were examples. Perlite ferrite group, 2 of them, and martensite annealed sorbite, not sorbet. Anyway, those are categories 1, 2, 3, and 4 with the different intensities level. Elastic limits at newtons per millimeter squared, tensile strength Newton per millimeter squared, and Brinell hardness, etc. All right? All right. So what this is how thick does the metal tubing you use to make a shotgun barrel have to be? Now, if you don't have any diameter changes inside of the barrel, it's a straight bore with the same diameter as the outside of the shell, for instance. That's what the D max referred to in millimeters. Then the thickness should still apply. The only place that you get a forcing effect or a focus of pressure or, let's say, resonating or rebounding effects will be right after the shotgun shell and into what is called a forcing cone. Pistols, rifles, shotguns, all of them have a forcing cone where the shell and bullet finally go to the part that does the business end of it, and this will in this case just be a constriction. That constriction has the diameter that's usually at that moment the declared inner bore diameter. So, category 1, 2, 3, and 4. Now, we ignore what they say. We just want to know how thick the barrel has to be at minimum for CIP standards. CIP standards are based on it won't blow up in any reasonable period of time that would be, basically the idea is that if you use even the maximum loads that you use, you should have no problems with these diameters in the metal if it's, in these examples. If you keep it to this minimum thickness for a period of time so long that it would be, if you had an accident or problem later, it would be easily assumed that it was just a damaged barrel or a defective barrel. So here we go. What is the minimum thickness? 2 millimeter. And it says it right there. It's 2 millimeter wall thickness. So if you start off with a chamber, that's D-max, chamber diameter of 20, maybe 21 millimeter. It's actually supposed to be 20 and a half, but it says 2075 for the chamber at the base. All right. Add to it 2 millimeters twice because you have that thickness on both sides. So the outer diameter of your barrel, amazingly enough, has to be 24 and a half millimeters, or just a little bit under an inch, right? Okay, now let me repeat this. This is them saying that if you manufacture from scratch as a company that makes these are the minimum amount where they'll actually bother proofing the thing and do it. Now it's 2 millimeters. That's right after the forcing cone. That's not even really the thickness you'd use, but let's say 2 millimeters. And the minimum thickness at 2 feet from the cartridge. 2 feet, 60 millimeters, which is the British version of it. We have 26 inches on 26 feet, 26 inches, excuse me, in the United States. Blah, blah, blah. I'm sorry. But anyway, at 600 millimeters, it can be down to half a millimeter thickness, depending. So make sure it's a millimeter. Or if you make the whole damn thing 2 millimeters, make it slightly heavier, it will not be able to blow the hell up. And most of the metal tubing you get a hold of is going to be thicker than that. That's like ridiculously thin. But then again, these are specialized metals. So of course they must be more expensive. And of course it has the thickness levels at 4 inch, 8 inch, about a foot, about 16 inches, and about 19 and a half inches. These numbers are picked because these are the cutoff points for various standards and legalities. And yes, the 8 inch or 200 millimeter length is minimum length, and the 1 foot or 300 millimeter approximate length are the minimums for flare guns. Yes, I had to set, I stuck that in. That's what she said. But anyway, let's go on to the next step. Yes, it's a wall of text, I'm sorry. A 378, 416, or 460 Weatherby Magnum firing an 800 grain or 26 gram bullet at 2,700 feet per second makes 7,000 foot-pounds at 65,000 psi. Or its CIP minimum barrel thickness is 6 millimeters, a little over 6 millimeters. So if you make the thing 13 millimeters bigger in diameter than the bullet, that would pass probably very easily. We're talking about minimum requirements for high-grade steel, right? That is the thickest one on the whole list on the CIP lookup. I went ahead and looked through it. So yes, the example I'm going to give of a 3.5 inch 18 pellet 1,200 to 1,400 feet per second double-aught buck 12 gauge shotgun shell with a maximum of 11,500 psi or 20,000 psi for proof testing for a double-barreled shotgun could be made from a $40 5-foot long chunk of 1 inch or 25.4 millimeter outer diameter and 0.095 or 2.4 millimeter thick-walled 0.810 inner diameter 4130 alloy steel round seamless tubing. Or you could spend double that and get an entire gun that's one barrel. Or just buy this kind of material and make a double barrel and attach it to that one barrel that's $80. Again, this can be done cheaply, it can be done safely, it can be done well, and that's aircraft grade piping that's also used for making roll cages for stock cars and that sort of thing. A steel barrel costs a lot less than any kind of ceramic, polymer, glass, plastic, or composite barrel that you could come up with to try to make some sort of rich man's 3D printed crap. But you can use it for the rest of the gun, I guess. Look up 500 Celsius or 900 degree Fahrenheit melting point aramids like Kevlars that could be molded into a straight and or spiral as the bore rifling. Or look up the sandbagged CPE chlorinated polyethylene or ABS acrylonitrile betadine. I don't know what ABS stands. I can't pronounce it. Or PLA polyacetic acid or PETG polyethylene terephthalate or just nylon that is used in 3D printable materials. And then I love this dire warning they give on the website. As the movement to self-manufactured guns with 3D printing grows, rapid advances in technologies have created an emerging class of really fucking expensive, stupid gun that can't tolerate jack shit. And it is reasonable to assume that those guns, of course, will be increasingly used in crimes, as they are invisible for airport screening security checks, just like the Glock and the apocalypse it caused. Because as soon as the Glock was put out, because you could get one that would not show up on metal detectors and really didn't show up on x-rays and still doesn't, because you can just buy the same thing and not do it to the airport grade Glock standards. You can get an 80% Glock lower that's not visible on x-ray. That was predicted and proved. It would cause a world the apocalypse. It did happen, didn't it? No? Really? So I was lied to? By literally everybody? Now they're saying the same thing about 3D printed guns because nobody ever made a gun out of plastic. See also fucking Glock. But yeah, this is a distraction. They don't want you looking up steel for making bicycles out of. Yeah, 4130 alloy steel is the same shit your bicycle was made out of if it was made out of steel. You've been riding a bunch of shotguns. So anyway, the definition of 12 lead spheres to the pound is a 583 grain, 0.72 inch, 72 caliber diameter round ball in a 72.9 or 73 caliber diameter barrel. Cylinder choke equals no choke. So let's look up shot types because I had this information I need to look up. So the infamous ones I'm going to be emphasizing here, but let's just talk about pellet diameter, pellets per ounce, or shell, big or other. So solid slug, 72.9 or 73 caliber. That's one pellet. I didn't even put in the weight because they're various weights. Tri-ball, I never heard of that, but the tri-ball, triple pumpkin ball, it's 3 of them in a shell and it's a 60 caliber. round balls shooting out of a shotgun. Next, then you have quadruple aught, which I'd never actually even looked up, but I found out, yep, it's a thing. And they're basically 37.5 caliber or 9.5 millimeter balls, an average of 5 per ounce, not per shell. Triple aught buck, 36 caliber or basically 9 millimeters, 6 of them per ounce. And then we have 33 caliber double aught buck, 8.38 millimeter or 8 of them. So basically, just pointing this out, quadruple aught buck would be like firing 5 357 or 38 caliber or whatever bullets, basically, right? One shot, basically like a magazine. But anyway, here we go. Then we get single aught buck, which is 32 caliber, 8 millimeter basically. 9 of those will fit in an ounce. Then you get number one buck. You get number one buckshot, and that's literally 30 caliber or 7.6 millimeter, and you get 10 of them per ounce. Number two buckshot is 27 caliber, 6.9 millimeter, 12 pellets per ounce. And then you get number three buckshot, 25 caliber, like 25 ACP, only these are round and short and not as heavy. And they go about 6.5 almost millimeters, or 18 of them per ounce. Then you get number four buckshot. This is the stuff that the FBI figured out had an odd characteristic of having pretty much the best penetration and stopping power without doing more or less than is needed, and became kind of a magic number. And these are 6 millimeters, and per ounce you can get 20 of them in there. So a lot of people do an ounce and a half number four buckshot and get on the order of like 30 pellets. That's literally like emptying an entire 24 or 25 caliber or 22 caliber easily pistol magazine all in one shot. Then there's F, and that's 22, actual 22 caliber, and 5.59 instead of 5.56, and they can hold almost 30 of them per ounce. Then you get T. I think that really refers to turkey shooting. That's just 20 caliber, 5 millimeter approximately, 31 of those per ounce. Then you get the BBs and triple Bs. Triple Bs are 19 caliber, you get 43 of them. Then you get 18 caliber BBs, that's the 46. And then finally B, which is 17 caliber, aka pellet gun diameter, and you can get 50 of those per ounce. So now you see, this is all the buckshot, etc. stuff. And I just thought I'd bring that up, just so you'd have the information. So yeah, you may need a minimum outside diameter of a specific, like 84.5 inch if you want to choke it. Thick badonk barrel. If you're thinking of building a gun, you also want to make sure you can put a choke tube in it. It's a joke, but yeah, you can put a choke in it. Chicken choke, turkey choke. If you're hunting chickens. Anyway, here are the data for it, and yeah, you can get away with something that's 2 millimeters thick on it. So make sure it's 4 millimeters larger than the minimum diameter, the diameter of the cartridge itself, and you should be fine. And thicker's better. And and you can start with a barrel that's the wrong diameter and ream it out. I can't help myself. Anyway, that's the video. Thanks for watching. Have a good day. Good luck with that. And if you were looking for whether or not it is actually technically safe, it's not the thickness of the barrel or the length. It's how tough and strong it is and how hard. So anyway, thanks for watching. Have a good day. Good luck with that.